I'll work through one more example showing how we can start with two solutions and come up with the net ionic equation. So in this particular example, we have cobalt chloride and sodium hydroxide, and I want the molecular, complete ionic, and net ionic equation for these. So we start by taking each of our reactants and writing those out. That'll give us our molecular compound. Cobalt is CO with a 2 positive charge. We have our chloride, so this is CoCl2, plus our sodium hydroxide. Sodium is 1 positive, hydroxide is 1 negative, so that's just NaOH. And then remember to do our products. We're going to take that cobalt, combine it with the hydroxide, and we have our sodium, and we're going to combine that with our chloride. So we're going to do COOH2 plus NaCl. So we have all of our pieces now, and I want to identify whether these things are going to be solids or aqueous in our reaction. So the two starting parts are aqueous, so we were given that they were solutions. So this is aqueous. Then we would check our products. And the hydroxides down at the very bottom of your solubility chart. So this is going to be a solid. Sodium is the first on our list on the soluble section, so that's going to be aqueous. So this would be your molecular equation. You do want to make sure to balance it. So I'm going to go ahead and come in here and balance this. So I'll put a 2 here and a 2 here. So this would be my complete molecular equation. I've got all the pieces identified and I've balanced it and labeled the states for each of my substances. Next one that we would do would be the complete ionic equation. So the complete ionic is going to be where we take anything that's aqueous and we split it into its constituent ions. So if it's aqueous, we're going to do that when you guys are working in OWL. There's an exception. So if it's aqueous, but the problem tells you that it's a weak acid or a weak base or a weak electrolyte, you are not going to split it up. Other than that, if it's aqueous, you split it, again, unless it states that it is a weak acid or base or a weak electrolyte. If it says either of those things, it will still be aqueous, but we're going to keep it together. So we're not going to dissociate a weak acid base or weak electrolyte. In this case, we don't have to worry about that. Everything is just aqueous, not weak acid or base. So if it's aqueous, we're going to split it up. So for my copper chloride, my cobalt chloride, we're going to have cobalt, and cobalt is going to be a 2 positive charge. So I'm going to do CO with a 2 positive, and then I have my chloride. Remember, a chloride ion is just a single Cl atom. It's not Cl2, so I'm breaking it down into the actual ions. For our sodium hydroxide, that's aqueous, so that's going to break down into sodium and hydroxide ions. For our cobalt hydroxide, this is a solid, so I'm going to keep it together. And then my NaCl, we're going to go ahead and break that up into those constituent ions. The purpose of that complete ionic equation is to cross out anything that I have on both sides, any of those spectator ions. So I'm going to check my cobalt. I can't get rid of that because I don't have it in the same form on both sides. Check my chloride. I can get rid of that. Sodium also can get rid of that one. And then we have hydroxide. Then whatever we have left is what we have for our net ionic equation. So again, that complete ionic equation is nice because it allows us to get rid of spectator ions. Whatever we have left over, we're going to represent as our net ionic equation. In the net ionic equation, we need 3 things. I need to balance it. So I need to throw a 2 in here. We need our ions to have charges, which I have. Those are already in there. And then I need to also include the states. So my ions are always aqueous, and my cobalt hydroxide was solid as we designated earlier on. So this last one is net ionic. That one in the middle is the complete ionic, and that first one was our molecular equation.